Hey, welcome back, guys. So today, our focus is going to be on lesson four, rational functions. And our goal for today is to be able to find the horizontal asymptote of a rational function. Okay, and so to get us started, we're gonna start with the definition for a rational function, right? So let's say that we have some rational function r of x, right, which is equal to p of x divided by q of x, right? P of x and q of x are going to be polynomials, right? So, in other words, a rational function is really just a polynomial divided by another polynomial, right? And so, what you see here at the bottom are two examples of rational functions, right? So, let's take a look at the first one. F of x is equal to 5x cubed divided by x squared minus 4x plus 2, right? And so, notice how what I have in the numerator, 5x cubed, right, is can be a function, a polynomial function on its own. And then what I have in the denominator, x squared minus 4x plus 2, could also be a polynomial function on its own, right? So when we have a polynomial function in our numerator and then another polynomial function in our denominator together, right, that forms our rational function, right? And then in the second example, we have a different polynomial in the numerator, 4x squared minus 5x. And in the denominator, we have another polynomial, x squared minus 2x plus 1. All right, so a rational function is really just a polynomial divided by another polynomial. It's a fraction of polynomials. All right, cool. So for example one, we're going to be learning the three rules to keep in mind when we're trying to identify the horizontal asymptotes of a rational function. Okay, and so let's say that we have some rational function p of x divided by q of x, right? So if the degree of p of x, right, the polynomial that we have in the numerator, is equal to the degree of q of x, the polynomial that we have in the denominator, right, then in order to get the horizontal asymptote, we would divide the leading coefficient of p of x by the leading coefficient of q of x. And the number that we get, that would be the value of our horizontal asymptote. Okay, but let's say that that wasn't the case. Let's say that the degree of p of x did not equal the degree of q of x. Let's say that instead the degree of p of x, right, the degree of the polynomial in our numerator was actually less than the degree of q of x, right? So if that's the case, then we would say the rational function has a horizontal asymptote at y is equal to 0. Okay, but if that wasn't the case, let's say that now instead the degree of p of x is actually greater than the degree of q of x, right? Then we say the rational function does not have a horizontal asymptote. All right. So whenever you get asked a question, or whenever you get asked the question, does this rational function have a horizontal asymptote? And if it does, what is it? We're going to keep these three rules in mind. Okay. And so let's take a look at some examples of us using these three rules. All right. So we're going to identify the horizontal asymptotes for these three rational functions below. Right. So for A, we have f of x is equal to 3x squared plus 2x minus 1 divided by 2x squared plus 1. All right. And so the first rule says if the degree of p of x is equal to the degree of q of x, let's check to see if that's true. Right. The degree of this polynomial on top is 2, and the degree of the polynomial in the denominator is also of degree 2. Right. So both of these polynomials have the same degree. Right. The highest power term inside this function for both of them is 2, and it is 2 on the bottom as well. So since both of these polynomials have equals degree, right, then all we have to do is divide their leading coefficients, right? So the leading coefficient of the polynomial in the numerator is 3, right? So my horizontal asymptote is going to be at y is equal to 3 divided by the leading coefficient of the polynomial in the denominator, which is 2 over here, right? So my horizontal asymptote for this rational function is y is equal to 3/2. All right, easy peasy. Now for b, right, we have a different rational function, 2 of x plus 4 divided by 2x squared plus 1. So for this one, right, we can clearly see that the polynomial in the denominator is of a higher degree. It's of degree 2, and the polynomial in the numerator is of degree 1. So let's take a look at our rules, one of our rules that deals with that, right? So it says if the degree of p of x is less than the degree of q of x, right? And for example B, that is the case. The degree of the polynomial on top is less than the degree of the polynomial on the bottom, right? Then we say this rational function has a horizontal asymptote at y is equal to 0. So for this one, we can just write y is equal to 0 for the horizontal asymptote, right? And then last one for C, we have this really long polynomial, x to the power of 6 plus 5x cubed minus 2x squared plus 1, all divided by x to the power of 4 plus 2, all right? And so here we can see, right, that the polynomial that we have in the numerator is of a higher degree than the polynomial that we have in the numerator, right? So that takes us to our third rule over here. If the degree of p of x is greater than the degree of q of x, right, which is the case for example C, then this function does not have a horizontal asymptote, right? So A and B did have a horizontal asymptote, but since we can see that the degree, right, of our polynomial in the numerator is 6, the degree of the polynomial in our denominator is 4. So clearly the polynomial in the numerator is of a higher degree. So we say there is no vertical or horizontal asymptote. So we can just write none. All right.